Alright everybody, welcome back to the channel. Today I'm going to be putting together my Wilderness Systems Recon 120, and I'm going to be showing you how I do that. I'm going to be installing this Haswing 1.0 brushless trolling motor and this Garmin Echomap UHD93SV. For the speed control on the trolling motor, I'm going to be installing this throttle lever. If you press it forward, you'll go forward. If you tilt it back, you'll go in reverse. And then for steering, I'm going to be using this electric steering box off of a Minn Kota power drive. And to control that, I'm going to be using this joystick to go left or right. And then I'm also going to be installing the two batteries, one for the trolling motor and one for the fish finder and steering inside this tray. And I'm going to have it to where all the cables are running inside the kayak so nothing is really showing. I'm going to be showing you a little bit of how I do this as I go. The first thing that needs to happen, I'm sure you can see, is the trolling motor comes with a long shaft. So I need to take the control head off and then shorten the shaft of this trolling motor. Start with these 4 screws on the bottom of the motor head. When you pull the top of the head off, the indicator light panel for your battery percentage is screwed into the top right here. So just remember that you have to undo that before you can take this piece all the way off. After that, there are 2 screws that hold this little cap in place right here. You're going to take that off. This pin right here is holding handle release knob in place. After you pull that pin, the handle part of the motor will pop out. And as you can see, it has these 3 wires coming out of it. That's for the potentiometer that's inside the handle for the forward and reverse. I'm not going to be using the potentiometer that is in here to control the speed. So what I'm going to do is cut these back far enough to where there's enough wire here still remaining that I can reattach the handle if I ever want to put this back to normal. So I'm just going to cut this piece off. Okay, so before you can take the head completely off, you need to remove this little speaker thing right here. And it's kind of just, looks like it's just glued into place. Undo these 2 screws right here. You'll release this little cap right here, which should allow you to pull the power cables out. These are the positive and negative leads that go to the battery. Okay, now that you have all the wires free from the motor head, you can see here on the side of the shaft there's a Allen bolt right there. Take that out. After you have that bolt out, the motor head will just slide up like that. So now that the motor head is off, we need to figure out how much of the shaft we're removing. But in order to do that, we need to mount it on the kayak so we can see how low it needs to be. But this kayak doesn't come with a transom mount, and there's no holes for one right here. Originally I intended to take one of the 3D printed transoms that I made for the Kaku Voodoo that's hanging up there and use that, but as you can see it's just a little bit too wide because this piece tapers in right here. So what I did was cut out a template on a piece of paper, transfer that into, I think this is a 3/4 inch piece of plywood that I had laying around. From here, I need to drill out the 4 holes for the mounting bolts for this. So now that the holes are drilled, I'm going to insert these screws that I definitely didn't borrow from another project I'm working on. And then I'm going to insert washer, wing nut on the bottom of each of these screws. After you get the transom secure and mounted, secure the trolling motor to the kayak and see how far down you want it to be. The top of the motor body is 1.5 inches, or about 1.5 inches below this keel piece right here. The top of the propeller blade is well below where the water line sits. In order to know how much you could actually take off of this motor shaft, I need to tighten that so the motor doesn't go anywhere, and then loosen this collar all the way because the steering box actually slides down over the motor shaft. But before it can do that, I need to remove this piece right here. It's this lever right here that lets you tilt the motor when it's connected to the actual Minn Kota power drive. But for our purposes, this bracket is just getting in the way, so I'm going to remove that real quick. To get this lined up and know how much you could actually remove from the shaft, you got to feed your wires through, and then this will just slide down the shaft. So this motor box doesn't actually connect to the motor shaft. As you can see here, there's this little notch that's cut out. And then in this collar, there's a notch that's the opposite. When the collar comes down, it locks into place. And if you tighten it against the motor, then the collar can't move. As the motor in here spins, it'll turn the gears, which will move this piece down here, and because it is locked into place with the motor from this collar right here, it will cause the whole motor to steer. Adapting this power drive steering unit with this collar will work for any trolling motor that shares the same shaft size as the Minn Kota Endura trolling motor. So that'll work for the Taswing 1.0, 2.0, and 3.0 motors, any of the Minn Kota Endura motors, and I believe most of the Newport vessels. This will not work with the Watersnake T24 or T18. They're smaller motors that have a thinner shaft, so this collar will not actually connect to it. After looking at this, it looks like I could take off about 7 inches without any issues, but I think I'm just going to leave this shaft the length that it is and attach the flag up here. Right, anyways, let's move on. If you notice, the steering head kind of spins a little bit, and in order for it to work properly, we need it to be in a fixed position. So what I need to do is find a way to stop this from spinning, and what I'm thinking is I'm going to use these holes right here that go all the way through. I'm going to connect something to it that drops down in here and locks it in place from side to side. Okay, so here's what I ended up doing to keep the steering box straight. I took 2 of these 3/4 by 9/16 aluminum C-channels, bolted them together, drilled a hole through the corner. So when I insert the bolt here, it will go all the way through to the other side. I will attach the wing nut, and then that will allow this to swing down into place. If I need to tilt the motor up for any reason, it kicks out, and then I can lift the motor up and tilt it back. Now that we've got the trolling motor mounted and the steering secure, we need to get it all wired up. To connect this throttle to these 3 wires that were connected to the old potentiometer on the motor head, I'm going to be using this cable here. It is a 3-prong cable. It plugs in and then screws together to be waterproof. IP67 rated, so it'll be, or you could submerge it in like 3 feet of water for 20 minutes or something to that effect. But regardless, it will keep the rain and splashes away from the electronics. I'm going to cut the end of the wire, then I'm going to strip these back. I'm going to use these little guys. These are self-soldering heat shrink tubes around all 3 of the wires once they're together. I'm going to get one of these. It's a piece of heat shrink that is lined with adhesive, so it will just provide a better seal around the 3 wires. And so I don't have wires running through the kayak, or like running down along the top of the kayak, I'm going to be using these gland nuts, which will run out of the kayak. As you tighten the nut here, there's a little rubber seal in there that seals around the cable. So it makes it not completely waterproof, but more waterproof than it would otherwise be. So now I'm going to strip these wires back. Then I'm going to take the same red, green, and black wires that were on this side, strip them back. Grab your little heat shrink tube, slide it over the wire. So before you heat shrink all of your wires together, get the outer heat shrink that you're going to use and slide it down over the wire. That way it's there, because you're not going to have room to slip another heat shrink tube over it once you have it all connected and whatnot. Now that all the various heat shrinks are in place, twist these wires together, slip the heat shrink tube over, and then hit it with a lighter real quick. And I'm not sure if you could see that on camera very well, but you can see when the solder melts inside there. So after you have got all your wires soldered together, next thing that needs to happen is this needs to be able to connect to the kayak. Going to get one of these gland nuts. The gland nut sticks in, and then you run from the inside the other nut that screws down. After you've successfully gotten those installed, you're going to take the other side of, or the other end of that wire, and feed it down into the gland nut. Once you have it out as far as you want it, you're going to tighten the gland nut to where it forms a seal around that wire. Repeat that same process over here for the steering. Next we need to connect the actual power for the trolling motor, and this part is going to come with a really important safety disclaimer. This trolling motor pulls 50 amps. In order to run 50 amps sustained, you need 6 gauge wire. This is 6 gauge wire. This, on these SAE connectors, is 10 gauge wire. 10 gauge wire is only good for 30 amps. And this other red wire that I'm going to be using to run from the back to the front of the motor, or from the back to the front of the kayak where the battery goes, is also 10 gauge. That means if I run this motor at full tilt for more than just a couple of minutes, the 50 amps will probably catch the kayak on fire. I'm going to replace these with 6 gauge wire to match the 6 gauge wire that came with the trolling motor, and all the wiring inside the kayak from here up to the front where the battery is going to be replaced with 6 gauge wire. But that being said, for testing purposes and for demonstration purposes, this 10 gauge wire will work, but it is definitely worth noting that you do not want to use smaller than 6 gauge wire when you are working with one of these trolling motors, because these motors do pull 50 amps. Alright, and then you repeat that for the other side. Okay, so this is the front storage compartment. As you can see, I have the old Ampertime 50 amp hour lithium ion battery that I've been using for pretty much all my projects out here in Hawaii. And it fits like perfectly in between these two things right here, but I don't have anything to stop it from sliding forward. But there's a little lip right here, and if I bring it all the way back, it kind of falls down there and more or less stays in place. And with it back there, my fish finder battery has room up here to get power to the Garmin. I'm just using a standard 12 volt outlet with this 12 volt plug. And I'm going to have this wire running through the side right here. And same with this. I'm going to have this plug coming out right here. Wires will come out the side of the tub and then run through here back to the back of the kayak, and then on the inside of the tub we'll plug into the battery right there and the Garmin battery over here. Now that I have this cable soldered together and connected inside the box, I need to take it and run it all the way back there to the back of the kayak and try to fish it out the other side. And then if I'm able to do that, then I will be able to finish the soldering back there at the back of the kayak and get the motor connected to power. At first, I tried pushing the cables down here with a broken fishing pole, but I couldn't get them to come all the way down in here. So then I tied this weight to the end of some fishing line and then slid the rod all the way back here, tied the weight to the tip of the fishing pole, and then slid it back to the end. Tied that line to the end of these cables and then pulled it all through. But when I got it back to here, towards the end, or towards the back half of the kayak where I could almost reach the cables again, the string came untied and the cables kind of pulled back up into the inside of the kayak. So I ended up getting this bore scope. As you can see there, it's looking down inside the kayak where the wires are running. And then I used this flexible claw thing to reach in and grab one of the cables so I could get them out. Now, just like I did up front and with these two cables, I'm going to drill a couple holes here and right here for the gland nuts. Then I'm going to run this wire, or these cables, through the gland nuts and then solder these to these two wires. Okay, so this is what it looks like when it's all put together and everything is plugged in. You can see here that the steering assembly is attached to the motor, and all the cabling comes down into the kayak right here. And other than how messy it is, there's no cables that are running up to the front. This power cable comes in here, goes in through those two gland nuts, and then up here at the front you can see where it comes out of the side of the dry box right there. Alright, so it's the next day. Last night got a little bit too dark for me to keep working out here, and it was getting late and I didn't want to disturb my neighbors. But before I went inside, there was just a couple things that I did. I took this gray plate right here that normally has the Wilderness Systems logo in it. I used the hole saw to cut this out so I can attach the joystick. This will be for the steering. And then inside here, it had this little plug piece in there, and then also there was some more plastic there. So I took the biggest hole saw I had, put a hole through the middle, and then I put it at an angle to extend the hole out into more of an oval shape. That way the joystick will fit through. And then I'm just going to use these same 2 screws to mount it back into position. And that'll work for the steering. Before I do that, I do need to run this cable inside the hole and then get it out through this hole. Also on the other side where the throttle goes, I cut out that same hole. I attempted to cut this out to fit this Gear Falcon throttle through it. It ended up coming out looking really horrible, and there was giant gaps in it. So I measured how wide the circle is, how wide these little end flanges are, and then how far apart they are, and 3D printed this, basically a replica of that. If you look at it, they are almost identical in size and shape, including the screw holes, but the rectangle on this is same size as the Gear Falcon box. And now you can see here there's no gaps, it fits flush. I did have to grind down the tabs right here because much like this top piece, you can see there, you can see here this little tab. They're designed to interlock together to be used with, I think, a flight simulator, but I'm using it to control the speed on my trolling motor. Anyways, so I had to grind those flat to fit through here, and I think I will also drill out these holes a little bit. That way this can mount together and just be screwed in all at one time. And you can see how it looks while it's actually in the kayak. So forward, neutral, reverse, just like a regular boat. Something else I did was I 3D printed this plate. These 4 holes line up with the mounting bracket for my Garmin, and these 2 holes line up with these 2 factory screw holes. And then I have it recessed right here, that way I could put the screw through, and the screw head will sit flush with the plate, and then the plate will just sit right here with the Garmin mounted about like that. Okay, so to get the joystick set up to where you can steer, you just get one of these little bipole relays. You have your positive and negative coming out from your battery. Then you have your positive and negative going out to the trolling motor. These 2 will end up getting connected to the end of this black wire. So then to connect these 3 wires to the joystick, you'll have the blue wire come in on one side, the green wire come in on the other side, and then on the back of the switch, the black wire will get split between the 2. So I will show you what that looks like when it is connected. I have the blue wire going to one, the green wire going to the other, and the black wire is on the other side connected to both. I stripped back some of the coating in the middle of this wire, wrapped it around the contact bolt, and then I also secured it on this side. So there's a light right here. It'll turn green when you move the joystick one way, and it'll turn red when you move it the other way. And if you get those lights, you can see that at least the relay is working and wired with your switch properly. But before I can show you what that looks like, I need to run power. So for that, I'm going to need to run a power cable from this hole up through the kayak into here where this power cord is sticking out of the side of the tray. I'm going to solder together this end, and then on this side, before I connect it to the power cable right there, I need to run the power cord for the Garmin through here because the Garmin is also going to be powered off of this same plug. And I'm going to put 2 holes right here, one for the power cord, one for the transducer. The Garmin comes with these 2 little cap things. You just fit it over the wire, and then using the provided screws, you just drill a little pilot hole where those go, and then mount these caps in place. I think at this point I've drilled probably 10 or 15 holes in it. Just a quick tip for you guys, if you are going to be doing stuff like this where you're cutting holes out of the kayak, if you save a couple of these pieces, say you get a scratch or you want to patch a couple of the small holes like this one that you made, you can get a plastic welder. It's essentially a soldering iron with a different shape for the head, and then you'll already have filler material that matches the color of your kayak. Now that I'm done cutting or drilling holes in the kayak, and I have a length of this cable cut out that is long enough for me to reach back to this switch or to this relay right here. This second heat shrink might not be completely necessary, but it makes me feel better having it there. So anyways, I'm gonna move that out of the way, and then I'm going to feed this cable down. So again, green is ground. This is coming from that switch. This one's coming from the Garmin. Twist those together. I'm going to twist my positive ones together. They're not particularly pretty, but they do work. They are soldered together properly, probably. And then heat shrink, fire. Now that all of that is done, I'm going to pull this out so I have room to actually plug this in. And then I'm going to get these wires tucked down inside the hull. That way you don't have any ugly exposed wires. And we'll worry about that one later. That's the transducer wire. So, open up the box, flip the switch to on. I haven't got around to putting that switch on the outside yet. And plug in cable. You can see the light just turned on right there. And we have power. So coming back over here, this should have power now. Green light, red light. It is connected properly. So now I can move on to, again, trying to get this wire fished in through here, or so I could finish connecting this to here and see if the motor actually turns like it's supposed to. Okay, here's how I'm going to do this. I got the green claw latched onto that weight, which is tied to this spool of line. I'm going to get this in here, and I'm going to, that did not go as far as I wanted it to. Hopefully you can see where it went to, kind of got stuck. End of the cable, get the weight wrapped around it, and if I pull on this end, you can see the cable going inside. And just like that, I have the cable. Probably cut it off about right here because I don't need that much slack. I'm going to strip this back, and using the red and black wires, I'm going to connect these two to these two. Then we can see if the motor turns. So I've got the wiring hooked up. It's connected to the battery, it's connected to the motor, it's connected to the joystick. So let's see if the motor turns. Oh my god. That's pretty cool. So it works. I'm going to set it up at a different angle, show you guys what the motor is doing. The steering isn't fast, and it doesn't automatically return to straight, so you're going to have to manually do that. So the only thing to do now for this, find a way to mount this inside here where it's not just hanging. It fits right there, so I'm probably going to get some double-sided tape and stick it right here, and then just stick it to the wall right here. And then you need to mount this. You can just turn it around if you get it backwards, but you need to mount it to where when you press the lever to the left, you're going to want the front right here to turn right. Not sure if you can see that back there, but that means it is, or the joystick is backwards, so when I mount it, I need to mount it this direction. Okay, so this is what it looks like when it's all mounted up. In my opinion, it looks super clean. It's at a good position relative to the seat. This is where they put the factory steering when you get the rudder system for this. But personally, I think the electric steering is better. Using really this entire setup, this joystick, the reverse pull relay, and actually the power drive head unit was not my idea. I will link or leave a link in the description to the video I watched that showed how to wire this all up. So if you want to see that, go check it out. He did a pretty good job on that video. But next, I need to wire together the throttle and show you how that works. I will also leave a link in the description to the video that I saw of the other guy put this together. While these two ideas aren't entirely original, I haven't seen both of them used together, and I definitely haven't seen them on this kayak. So I am pretty excited to see how this turns out. I'm going to get this black wire right here pulled through so I could show you how I'm going to finish wiring this up. So I have the potentiometer wired up right now. As per the video I saw that gave me the idea to use this Gear Falcon throttle lever, I had to replace the potentiometer that came with the Gear Falcon, with a 10K potentiometer. And then I have it wired up from left to right, black, yellow, red, with a 1K resistor on the black and the red. I don't know why, but that's what that other video showed, and he said that the resources where he saw how to do this said to do it that way, and they have an explanation. So if you're curious, go check the link to his video. The knob for the potentiometer is right here. It's a gear, lines up with, not sure if you can see it real well, but that gear in there. So when you push this forward or back, the gears connect and then turn this. Right now, it is in neutral. If I turn it, you can see now the motor is spinning. If I turn it back, it's off. Now it's going backwards. Now it's off. Something I didn't consider when I was printing this is that the board sticks out a little bit, so this won't actually go down there with the board on. So you just undo those two screws, put this through the plate, and then attach the board. So I'm going to adjust how this connects to the screws right here. Will happen off camera. So as you can see, there's a throttle. The only thing I have left to do on this is to finish mounting it to where it sits nice and flush like the steering does. And then I'm going to finish installing the Garmin. I need to take the transducer cable out because I can't actually install the transducer properly with this cable already in here. And I will show you why in a minute. Okay, so here's where I messed up on the fish finder install. This is the storage area for the kayak behind the seat. And if you come straight down here, this is where the transducer mounts. They have the holes already mounted. Like before I could run this through the hole, I have to run it from the outside of the kayak up through this scupper hole. And now I should, let's see. Get that a little bit. Do that over to me, hold it in. Sorry. Don't hear any of these. I'm pretty sure I just put that on backwards. Completely. Is it on the right? Okay. No, press it. Pull that through. So now, as you can see, the transducer sits almost parallel with this flat part right here, but it is well below this center the center hole right here and the outside. So unless you have a stick or something that just drags through up under right here, your transducer is fully submerged and protected without having to drill any additional holes in the boat. So that is pretty much where that lives now. Let's get back on top of the kayak so I can show you how I'm going to finish running the transducer cable. You can see the cable coming up down there through the scupper hole, and then it runs down along this channel. You can see this little divot right here. There's one up here as well. This kayak came with some of these guys and the screws to mount them. Basically, they just go over the cable for your transducer, and then they screw into place in these holes that are pre-drilled. All you have to do is pop these little black plugs out. Now they don't put tension on the cable at all, but they at least prevent them from popping up and flapping around. So after you have your cable secured, you're going to need to drill a hole for the transducer cable to go through. But the next thing to do is get this cable back down to the front of the kayak, and then I could run it through like you saw before and get everything plugged in. And there you go. So I wanted to do this part of the ramp, but there was a boat pulling down and I didn't want to be in their way. So I'm gonna go through this overview out here on the water. And here we've got our batteries. The orange box is a 15 amp hour 3S lithium ion battery pack that I put together. and that is powering the steering box and the Garmin depth finder. And then here we just have our 50 amp hour lithium iron phosphate ampere time battery, same one you've seen a million times if you've watched any of my videos. I have the cable for that, or for the motor, running through the side right there, and I have the cable for the accessories running through there, keeping this box still sealed and waterproof. Coming back to here, I have my Garmin Echomap UHD93SV. From the seated position, it's out of the way, and that chart is big enough that I could see everything that I need to see. Back here on the left, I have the steering. You can see it turns the whole motor back there. And then I have the throttle here on the right. And then got my kayak crate. I showed that in another video, but it is completely waterproof, still functions as a cooler if I wanted to empty it, and it has 4 rod holders on it. Then I have a 3D printed transom that I made. I made that for a different kayak, but the holes line up with a power pole mini mounting point, so it should work for most kayaks. The channel that it's supposed to fit in right there is tapered a little bit, so it was slightly too wide, so I did put a 1-inch spacer under it. Then that is the Minn Kota Power Drive steering head, and in the water is the Haswing 1.0 65-pound trolling motor. Moving up, I have that cap right there that allows you to mount any Railblaza or Yak gear accessories. Moving up to the Railblaza flag, and on top of the flag I have the 360 cam for a kind of over-the-shoulder view. The only thing left to do is actually test this out. You can see we're just kind of drifting right now, so I'm going to slowly increase the throttle until we get to a good speed, see how much throttle it actually needs. With just enough throttle to where you could feel the engine kick on, we get up to 1.5 miles an hour. Increase just a little bit more. Okay, so we're just over 2 miles an hour. When the wind picks up at our back, we get moving a little bit faster. But if you see here, the throttle is in a perfectly vertical position. That is neutral. And straight up and down seems to be the ideal trolling speed. I don't know about you, I tend to troll at about 2 miles an hour. So let's kick this up into full speed real quick and see how fast it actually goes. So it looks like 4 1/4 is about the max speed for this setup, the way I have it. It's not the fastest motor I've ever seen, but with this throttle right here, you don't actually get full range out of the potentiometer. The throttle lever I have does limit it a bit to how much power you could actually give it. So that's not exactly ideal, but I am running 10 gauge wire at all of the connection points, so I don't want to be running at 50 amps the whole time, which is what the max draw on this motor is. Because while 10 gauge wire can support 50 amps for short bursts, it will overheat quickly, and I'm not trying to catch my kayak on fire. But yeah, this is it. This is so far my favorite motor setup with the steering and the throttle. To use this throttle, you will need a brushless trolling motor. This one won't work with a standard brushed trolling motor like the Minn Kota Endura or the Newport Vessels trolling motors. But for reasons that I talked about in a previous video, I personally prefer the brushless trolling motor anyways. It's more durable, more reliable, and I could do more projects with it, such as this one. But this steering will work with any trolling motor that has the standard size motor shaft. Anyways, yeah, that's pretty much it. I hope you enjoyed the video, and I will catch you on the next one.